Okay guys, I'm going to go through a few more examples from 6A just to clarify a little bit more about the number of modes and symmetry or skewness. So here are 4 examples. You can see that this first one is what we call unimodal. Okay, this is unimodal because it's the height of 1,000 randomly selected adult women. The distribution of these heights is going to be what we call single peaked. Because the woman will have a height that's at or near the mean or the average, so they'll all be towards the middle here of this peak. You'll have a few that are a little shorter, a few that are a little taller, but it's going to have one peak in the data. The second one that we see here is the time watching football. This is showing the time watching football for 1,000 randomly selected adult Americans. And up here it says that we're specifically talking about in January. Of course, and we know in January that there's going to be a ball game that's going to be going on those Sunday afternoons. We have some casual fans that like to watch our ball, but also it's gonna peak during the ball games, and then there's obviously going to be another peak. We have big fans who might watch more than once. Of course, we have a Super Bowl that goes on in January, so you would call this one bimodal. One mode represents the most common time that we watch for big fans, and the other is just the more casual fans. Okay, and so you can see here that the casual fans are going to be watching TV less than the big fans. And so you think of this axis down here as the amount of time that you spend watching TV. So a number over here under this first peak is going to be less time than these guys who are big fans, because the casual fans watch TV a little bit less than the other ones do. Okay. And then on part C, it says weekly sales throughout the year at a retail clothing store for children. We know that that's obviously going to peak through the seasons. We have to go shop a little bit more. In the spring, you're getting ready for summer, then you go back to school and you have to buy clothes again. Then the holidays, often those go up because the holiday shopping. So the sales are going to peak at different times of the year. This would be several modes. So there's more than one, and in fact there's more than 2. So we have several modes in this example. And then this fourth one here is the number of people with a particular Social Security number and have the digits 0 through 9, so you can see the digits that are listed here on the horizontal axis going 0 through 9. And the number of people with those, the last digits of your Social Security number are essentially random, so the number of people with different last digits 0 through 9 will be about the same, or it should be about the same. That is, about 10% of all of them should end in a 0, 10% will end in a 1, 10% will end in a 2, 10% will end in a 3, and so on. So it's therefore a uniform distribution, so there will not be a mode in this example, since that will be spread out evenly there. Okay, so that's about the number of modes. Now I also want to talk to you for just a second about skewness. I know we had a little bit of confusion on how to describe the right and the left skewness, so hopefully this will help out just a little bit. These distributions that you see up here are all what we call symmetric. The left half will mirror the right half. Even if you have more than one peak, you can see here that this one still has symmetrical data being shown here because it has a peak, and it reflects over this line of symmetry right here. A distribution that is not symmetric must have values that tend to be more spread out on one side or the other, and in this case then we say that it's skewed. Okay, so this was our vocabulary word that we talked about, the data being skewed if it's not symmetric like we saw up here. Okay, so in this figure we can see a distribution in which the values are more spread out on the left, meaning these values are outliers, that some of the values are outliers at the low values. So it's left skewed when your outliers are on the left side. And then such a distribution is called left skewed, or sometimes we call it negatively skewed, because it looks as if it has a tail that has been pulled toward the left of the data. Okay, so the tail of the data kind of looks like the tail of it right over here is where we have some of it spread out. Okay, so this first example here, just to kind of give you a little more an understanding of that. So I took that data, and this was the 3 that we talked about in class. These were the 3 examples. So this first one that is left skewed is the one that we talked about with the driver speed, where a patrol car is checking your speed using a radar. Okay, and we can see here that this data is going to have outliers here in the low value. So the tail of the data is going to be over here in this region right here. Okay, and so I'm actually going to give you some numbers to go with it that might kind of help you see it a little bit better. So let's say we're looking at this data for the speed of cars when that patrol car is present using the radar detector. Okay, and so we can see here, let's use this set of data. We can see that if the speed limit, and that's one thing that's important here, we're going to say that the speed limit here is 65 miles per hour. Okay, so if you have a patrol car there that's detecting how quickly everyone is moving, detecting their speeds, what's going to happen is you're going to have several people that are going to realize that, and they're going to definitely be sure they're going the speed limit, which we can see right here is 65. Now, several people just kind of naturally react, and we go extra slow when we see that radar detector. So there's probably going to be some down here that just speed down even more, or excuse me, bring their speed down even more than necessary, and they go well below your speed limit. And then there might be a couple that go ahead and just kind of keep going and don't really worry about it too much, and they're still traveling a little bit above the speed, or maybe they didn't notice in time to slow down enough. And so this could be a sample set of data here. If we were to take this set of data and try to find the mean, we're going to find that our mean, because there are several people down here that are going even slower than they have to, it's going to pull our mean, or our average, down. So if I added all these up and I divided by 12, I find out that my mean is actually below 65 miles per hour. And my median also ends up falling below that because I have more up here at the front, and whenever I count off the front and the end and I work my way into the middle of my set of data to find my median, I'm going to realize that my middle has to be between these two. Okay, and between 62 and 62.5, or excuse me, 62 and 65 is actually 63.5. So this median is also lower than 65 miles per hour. Okay, so what I have so far is that my mean is larger than the speed limit, or excuse me, it's lower than the speed limit, so my mean is less than 65. Okay, and then if you look down here, I also have that my median is also less than 65. And then I know that my mode is the one that's the most often, which I can see right here. There are 4 65s. Okay, so 65 is going to be my mode. And I can look at my mode and I realize that my mode is actually the largest of these three values. My mean and my median are both lower than my mode. Okay, and what happens is if it's going to be left skewed, that's what you're going to see. So if you look at the numbers, if it is left skewed, your mean and your median are going to be smaller than your mode. So if I'm thinking of this from left to right as the speed that the cars are going, then I'm going to realize that my mean and my median are both to the left of the mode. So I have my mean listed, my median, and then my mode. And my data is going to be skewed this way because these few people that are going well below the speed limit, the ones that are above are on this side. So I think that will hopefully clarify that for you guys a little bit. If you think of this horizontal axis as their speed, so this down here may represent going, around 60, whereas this up here may represent going closer to 70 miles per hour. And so the data is actually going to show the mean and the median to be to the left side of the mode, which is going to skew it left skewed. Okay, so the second example here is a right skewed, and this one's right skewed. This is about the number of books that are read by the 5th graders throughout the year, and you'll find that the mean will actually be higher than the mode, and the median will be higher than the mode as well. So here's an example of that data set. If we see the majority of the students right here, if we go with the mode, we would say that the mode would be 25. But if we take all these and we look at them together, there's going to be a few students that may be read below that, and then there's probably going to be some that are just avid readers. They're going to read high above that. But if this is possibly our goal, like for the year, of reading 25 books, then there's going to be a good bit of students that hit that goal and are just happy to be at the goal. Maybe a couple that don't quite make it, but then there's always going to be several that'll go above it just because they enjoy reading. And so this would probably be right skewed, because if you find the mean, you get 26.08. If you find the middle, whenever you go and you count to the middle of this data, there are 6, 7, 8, 9, 10, 11. There are 12 pieces of data here. So when you count front end, front end, front end, because that's an even number of numbers, the middle is going to actually be between right here because we had an even number of data. And so between 25 and 26, we have 25.5 for our median. And our mode was 25. So we can see here that the mean and the median are both higher than the mode this time. And so what that's going to do is what you see in this picture. Your mode, where most of the numbers are, is going to fall here, but there'll be a median that's a little higher and a mean that's a little bit higher because we have these outliers. We have these kids up here that are reading a little bit more than the other ones. So that's going to make the tail be on the right side. It's going to kind of pull the mean and the median this direction to the right. Okay. And then our last example is symmetric, and that was the one about the heights of the sample of women. And so you could take your sample of women, and if you were to list them, and you would find that here that generally the women are going to have like an average height, and that will be your mode. Most of them will kind of fall towards a specific area. Right in here is going to be your mode. And then if you had a few below and a few above, those usually balance each other out pretty well. And so like here, if we were to add these and divide by 11, because there's 11 pieces of data here, then we get 65 for our mean. If you go and you find the middle, this is an odd number of data, pieces of data here. And so when you mark these off, the middle is actually right at a 65. And then the mode at 65. So you see that these are all the same, or they're going to be fairly close to each other whenever your data is symmetrical. Alrighty, so there we go. We have that to kind of show you guys a few examples of how, if it's symmetrical, that your mean is going to equal your median and your mode. And I hope that helps out a little bit, just to clarify with you guys the difference between the left and the right skewed and then the symmetric set of data. All right, so thank you. Just keep working on 6A.